How about we do 10A? Want to do 10A, Jesse? All right. So here it is. We're going to start with this guy here, 10A. 16 grams, 16.0 grams of methanol, CH3OH, dissolved in 250 grams of water. And you are to find the freezing point and the boiling point of these certain solutions. All right. So I'm going to minimize this. Go to the, get our little page up. Here you go. So for 16A, excuse me, 10A. 10A. There you go. So it says here 16 grams. There's 16 grams of methanol, CH3OH, and it should be dissolved in and 250 grams of water. Correct? All right, sounds good. So now we are to find the boiling point and the freezing point. What do you need for the boiling point and the freezing point? What do you need? What's the first thing you need? You need the constants. And so the constant for the solvent, remember the constant is for the solvent. So the boiling point of water, the constant, and I'll make sure it's just specific for water because it changes with your solvent. It should be 0.512 degrees Celsius per what? Molal. Thank you. Right? And then you also do the same thing here for freezing point. Freezing point of water. And it should be negative 1.86 degrees Celsius every what? Molal. Excellent. So there it is. So we have these two constants. So what do we need now? What do we need now? What's the thing that we need now in order to solve for the new boiling point and the new freezing point? Kilograms and molecular mass. You do need the molecular mass, and you need to change those kilograms for what? What are we looking for? Molality. That's right. So you need the molality for both. If you find the molality, then you can easily find the new freezing point. And how do we do that? Just like you said, we take 16 grams. The book says 16.0, so we'll keep it that way. CH3OH. And I'm going to take the liberty right now to convert 250 grams of water to kilograms, so it should be 0.250 kilograms of water, so that we can set up for our molality. And now I need to convert these grams to moles. 1 mole, and you said we need the molecular mass, so let's calculate it up really quick. There's 4 hydrogens at 1 each, and then there's 16 for oxygen, so that's 20, and then carbon is 12, so that should be 32 points. Oh, my battery's running low. 32.0 grams of the CH3OH. All right, here we go. So it says 16 divided by 32. What is that? 1/2. So you should have 1/2, and then here's what you have. Look, you have 0.25, which is the same as 1/4. So you have 1/2 divided by 1/4. What is that? It's 2. Should be 2. So let's write this down. So you should end up with 2 point. It looks like 3 significant digits. 00 molal of this solution, CH3OH. All right. So now that we have the molality, all you do now is you're going to take the constant and you're going to multiply it by the molality in order to get you the new boiling point and the freezing point. So let's start with boiling point. Boiling point, BP. So it's going to be 0.512 degrees Celsius per molal, and we're going to multiply this by our molality. Okay, let's push pause here. There you go, we're back. All right, so now we have 2.0 molal, and then the molalities cancel out, and then so it'd be 0.512 times 2. What is that? 1.024, is that what it is? 1.024. 1.024 degrees Celsius. And the normal boiling point of water is 100 degrees. So you add it to this 10.24 degrees Celsius. And it gives us a new boiling point of 101.024 degrees Celsius. Then you do the same for freezing point, but instead you use negative 1.86 degrees Celsius, this constant here for freezing, and you multiply it by, once again, 2 molality. The molality cancels out, and this should be negative 3.72, is that it? 72. And then the normal freezing for water is 0 degrees Celsius, and then you're going to add this, so it means minus 3.72 degrees Celsius. So that gives us a new freezing point, negative 3.72 degrees Celsius. Look at that.